Hello friends, so welcome to another video. In the last video you saw how to use the Bluetooth feature in the ESP32 Boffin kit of Blix, and we saw how to switch on and off using Bluetooth, and now we will extend it further and see how to run a motor or run a car which has two motor, two wheel, left and right wheel, and how to navigate using Bluetooth remote control. So let's see. So this is the block coding. That's what running the motor, and yeah. So here is the code. So first of all, when ESP32 starts up, that's what you will be seeing in any Arduino based coding platform. So where you will have a setup function. If you see in the C++ side, there will be a setup, which is this one, and there will be a super loop or infinite loop that will keep spinning until as long as the microcontroller is on. So this startup is the setup. So we are telling what are the things we have to set up here. So okay, I'll move this video for some time and let's see back to back C++ and the block coding. Okay, so I'm not using these two variable. These are the custom variable I have declared. So if you go to the variable part, you see left motor, right motor, wait time ch, and Bluetooth ch, means from the Bluetooth what are the characters coming I'm trying to catch. So this left motor and right motor variable I have declared, and I'm storing the number, the pin number. So left motor is connected with pin number or port number 2. So if I bring it back, port number 2, 1, 2. So this is the port number 2, and that's connected with the left motor, and port number 20. So right motor pin number 25. But what is the port number? For that you can check the Blix manual. I will bring it in a minute. So there is a mapping between the port number versus the pin number, and this is the mapping. So if I bring it close, yeah, so the port 2 is actually pin 2, so there is no confusion. But otherwise port number pin number 25, if you see here, which is correspond to port number 5. So that means it is connected to port number 5. So in here you will see in the port number 5 the motor will be connected. So as of now I have removed the connections, but just know that you have to connect to the port number 5 to the right motor, and port number 2 to the left motor. Yeah, so that's what it is saying. It's a reminder to me, but I'm not using this variable. So yeah, you can remove this first two lines. Then coming to the Bluetooth connection configurator. So this one is what creating the Bluetooth connection. This one is what will broadcast your Bluetooth device in the air, and then other device will discover you. So this is the part which is supposed to run only one time. So that's coming here, begin and this thing. And then what will continuously come is how read and write. So if you want to write something in the Bluetooth, that will come. That I don't have right now, but if you are reading, because I have to read sitting inside the Boffin kit, that what data is transferred from your mobile device or any kind of remote control to the car, what is the instruction. So to know that, you have to keep iterating and keep reading the pin. So that's what is happening here. So yeah, we'll come back to the block coding now. So yeah, if you see from the block coding perspective, this is the first effective line I have, and this wait time is something I will be using. Yeah, so forever loop, this is the forever loop, which is corresponds to the loop here. So this loop, what we are doing here, so we are saying repeat until the digital pin 4 is on. So what is this digital pin 4? So digital pin 4 is actually in my instruction set. If you see, pin number 4 is port number 3. Port number 3. So the port number 3, I have a IR sensor. So if I block the IR sensor, I don't want my robot to listen to the remote control. You might say move, and it is actually seeing some obstacle is in front of it, so it should not obey you. This is the first precedence. It's kind of a, you can say it's a kind of interrupt, kind of, but it's not interrupt actually, but kind of. So this is giving the higher precedence, so it's checking, and what we are doing is we are immediately stopping. So it is entering. Okay, so this is where it is entering. So if it is if it is sensing something, it will come into this repeat until block. So this will keep repeating until this condition is not satisfying, and then it will come out and really listen to your remote control. So this is the part of the code. Repeat until is taking care of your IR sensor's signal, and it's keep honking. So this is the pin number 33. I have connected with a buzzer, and it's creating a beep beep. So beep for 0.2 second, and then no sound, and then one more time 0.2 second, and then one more no sound. So beep 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 beep, like that. So that sound will keep coming until you move away, or until you move the obstacle in front of it. And once no obstacle is there, it will not enter to the repeat block, it will come to the next block, which is the if condition. In the if condition, we are checking if any instruction is there from the Bluetooth device. So if you have paired the Bluetooth with your laptop or your mobile Bluetooth app downloaded from Android, we can check. We will have another video on how to download and how to configure and connect. Yeah. So anyway, you have connected, and then you are trying to send the signal, and this is the place where it is detecting that, yeah, I got a command to execute. Either go, move front, go back, left, right, stop, all these things will come. These 5 commands you can think. Now I'm checking the command I received via Bluetooth. It's just a single character I have sent as of now. So if it is a single character, what is the ASCII value? So 97 is the ASCII value of small a. So that means it is checking if I have sent a small a character, which means forward. So it will move forward, the car will move forward. What is the meaning of car move forward in the lower level? That will come. That's a function I have declared separately. I will come to that. So this is very easily readable, right? Instead of having the complication of to move forward, I have to send a high signal to both the motors relay, this motor driver board. So those detailings I have abstracted into a custom function. So this is called my block. In my block, I have created custom functions. Using that, I have abstracted them, and here I am using, so that you can understand the flow without going into the details. Okay, moving to the next. So the wait time. This is the wait time I have declared here, so that anytime I can change and see how is the response. So it will move forward and wait for this much time, and then it will look for the next command. That's way. Okay. So A is for forward, then 98 is small b. If you press small b from your keyboard or somewhere, it will go left. I will come to the OR part later. So key left, and then 99 is right, and 100 is back, and then if nothing is given, it will stop by default. So if you pressed a button forward, it will go forward, and then it will stop until the next command comes. So this is the stop. And now I'm coming to this OR part. So I'm saying either I can send a signal, or I can send a number 55 ASCII value. What is this 52? So what is this 52 ASCII value? I don't want to know. I have connected with one of the Bluetooth Android app in my mobile, and they already have a ready-made arrow key, left, right, up, down arrow key. Let me try to get a screenshot of that. Yeah, let me move it. So you might see a screen like this in your computer, in your mobile, and then these are the buttons. You need to figure out what this button, once you press this button, what is the signal generated by the mobile device, the mobile app. So that number you have to make a note and write into the if condition. So up, down, left, right. So whatever buttons you have to run a separate code and find out what are the numbers, and then you have to punch in those numbers. So I have punched in the up, the left arrow key, right arrow key, up, down, all the numbers I have made a note, and then I have typed it. So either you press a button, a key from your computer or laptop, or you use your Bluetooth app. Anything you do, both, it supports both of your laptop and the Bluetooth app, the mobile app. So that's what this OR means, and what it translated into this is the translated value in the C++. This is how it does. And then left and right, whatever I have abstracted, those abstracts are a function call, and the content of the function will be somewhere in the top, this stop, front, left. So we'll come to the block coding, and then we'll discuss about this. Okay, so coming down, you have back and front. So I think this is all, yeah, that's all of the main code. Let's describe the back, front and all these things. So what I have to do, what is the challenge, let's see. So first of all, I will discuss about the forward. If I discuss one block, I think all the other block will be just repetition and little bit of change. So first of all, to make it forward, if there is a forward, there have to be backward, right? So that means you have to rotate your motor forward and you should have a way to rotate your motor backward. So how to change the direction of your motor is covered in the front direction function. That's another function. So I'm calling another one function from other function. So how this front direction is mentioned, you see this digital pin 15 and 26. So here there is something to understand. So how, look at this, look at the let me show you the camera screen again. If you see this ESP32 board, you see one motor can be connected with only one port. So how can I send a signal to control the speed, as well as how can I send a signal to control the direction? How can I do two things using a single bunch of cable? That's where is the magic. So I will bring you back to the manual. You see each port has connected with two pins. So you see for example, port 5 is connected with port 27 and 14. So you see every port has four cables connected. So if you see four cables, that means one is VCC, one is ground, and there is one more for signal. What is the other one? That's where for the other signal. So every port has two signal pin and one VCC, one ground. That is where the magic is. You can use your ultrasonic sensor where you need a one trigger pin, one echo pin. So those kind of things can be supported by this bunching, and you need less number of complicated ports around it because of this bunching or grouping. So coming back to our topic, so this motor, whenever you connect to a motor, one of the signal pin is actually connected to your PWM signal, which is controlling your speed. What is PWM? We can discuss, or you can check in Google. I'm not covering it here, but the other pin could be PWM or digital pin, just a simple digital pin, because PWM is also a digital pin. The other pin you can use it just as a high or low, just as a pure digital pin, and that pin is going to forward or reverse your direction, and that instruction is translated by this DC motor. So this DC motor, I have unplugged the pin, but it is that same 4 pin thing. So if you connect and send that one of the signal as forward backward and the other signal as PWM, which is like a pseudo analog signal in a form of digital by changing the duty cycle and all, so leave that. So that is one pin which is going to help your controlling speed, and the other one is the direction change. So these two pin we are covering here along with the VCC and ground. So yeah, so DC motor, what is DC motor block? It's basically a relay which is supporting speed control and other things. So I'll leave it. Okay, so coming back to this, so you see the front direction, pin number 15 and pin number 2. So pin number 15 and pin number 2. So let's see in the manual. Let's see in the manual. Pin number 15 and pin number 2. Pin number 15 and pin number 2 are actually belongs to port 2. So that means if you have connected your left motor to port 2, that means pin number 2 is the PWM pin and pin number 15 is the direction pin. So for this case it is a direction and PWM. For a ultrasonic sensor it will be a echo and trigger, and both case it will be for ultrasonic sensor both will be a digital pin. You don't need any analog pin for that case. Yeah, so that's what. Coming back to the code, so you see this pin number 15 and pin number 2 both are actually belongs to left motor, and pin number 25 and pin number 26 belongs to another motor, right motor. So now you can understand, I think. So the forward means first change the direction to forward, so the motor moves forward, and then power on both the motors. So why it is 125 and it is 100? It's a mistake. You can change both to same. But if you see one of your motor is little less powerful, you can adjust them such a way that your both the motor moves the same speed. Otherwise, what will happen? Your one motor moves little faster, and that as a resultant the whole car will turn in one direction that you don't want. So that kind of calibration you might have to do here in a bare hand, or you can come up with a calibration solution. So I'm not going to that. Similarly, left, so front direction, for left, right and front, all cases the motor have to move front. So for all of them I have tagged the front direction, and then I'm moving the motor based on, so it's a left means only one motor will be up. What is the motor? So if you're going to left, that means your right motor will be on and left will be off. So that's what is happening here. So that means 25 is the left motor which is off, and the 22 is the right motor, and the reverse is for the right. And the stop means this front direction is not mandatory. For stop you don't have to define direction, you just make both of the motors stop. Send PWM signal of 0 duty cycle. Okay, and then front direction, back direction, this is the thing you just now saw. Make it low, make this pin low, that will give a signal to the motor driver both to say go front, or high means back. And then back means this is the only time when you will be calling the back directions, and then followed by you will be powering up both the motors. So this back and this front, forward, both the below PWM pin will look same, just the direction is different. That's what expected, right? So yeah, that's all about. And if you see the corresponding code in the C++, that also reflects the same thing. And that's all about the motor code. And this code I'll be saving and publishing with my YouTube video. So please keep following, and see you in the next video. Thank you.